Hello ladies and gentlemen, let us meet in our 7th lecture in electrochemistry, which we call electrolytic processes. As we have already said, my name is Tapiwa Gwamure, and I will also look on electrolytic processes because we have said that initially we have two types of cells: galvanic cells and electrolytic cells. We have already done justice to our galvanic cells, so now let us look on what we call electrolytic cells. These types of cells, they actually convert electrical energy into chemical energy, which is the opposite of that one of our galvanic cells, which in each case our galvanic cells, they actually convert chemical energy into electrical energy. And we have already highlighted that under galvanic cells, our cells, they are self-sustaining, meaning to say that there is no need for us to have a continuous supply of energy in the process. But in electrolytic cells, we have said that there is need for us to have the application of electrical energy throughout the process. So as a result, we have our first example of an electrolytic reaction, in which we have the electrolysis of copper to chloride solution. When we are talking about electrolysis, we know that lysis means to break down. So electrolysis itself is the decomposition of a substance using an electrical current. So in this case, we are actually decomposing our copper 2 chloride solution using an electrical current. So this one is an example of an electrolytic process. So in this case, our copper 2 chloride is to be dissolved in water, and then a current is passed through the solution. When copper 2 chloride is dissolved, it dissociates into its ions. So let us see what's happening. We're saying our copper 2 chloride, which is in solid form, is actually dissolved in water, and it will dissociate into its respective ions. That is the copper 2 ions and the chloride aqueous ions. Right? So at the end of the day, we see to that these copper 2 ions are right there in the solution, and our chloride solutions are right there in the solution. Right? And then we are saying that carbon electrodes, these two electrodes which we see in our reaction container, these ones which we have already highlighted, that these ones are carbon electrodes. Right? And these carbon electrodes, as you can see, this one is positively charged. This one in itself is going to be our anode. Remember, in galvanic cells, we say that the anode is positively charged. But in this case now, in electrolytic cells, our anode is positively charged. If we actually come to this side, we have our, on this carbon electrode, is negatively charged, but under galvanic cells we say that the negative electrode itself is our anode, but in this case now our negative electrode is the cathode. Right? So you are supposed to note the differences which we have between the two processes, but our reactions which are taking place, they are not going to change. That is, at our anode, that is where oxidation is taking place, and at our cathode, that is where our reduction is taking place. Right? As you can see in our diagram, the electrode connected to the positive terminal, this one, is going to actually attract some negative ions. That's why you see to it that our chloride ions here are attracted to the positive terminal, and the one connected to the negative terminal will give up electrons to the electrode and become chlorine atoms, which combine to form molecules of chlorine gas. So as you can see, the positive ions there, they are going to be attracted to the negative electrode. So let us see what's really happening in our electrolytic processes. So we are saying that initially we have already highlighted that we are going to have our chloride ions here. They are being attracted to the positive electrode, and so we have our two chloride aqueous ions. They are actually going to be attracted to the positive electrode, which is our anode. So we're going to have our chlorine gas there, right, plus our two electrons, right? So as we can actually see in this particular reaction, we have actually formed chlorine gas by losing two electrons from our chloride ions. So this one is an oxidation reaction which is taking place at our anode there, although our anode is now positively charged. So our chlorine gas is given off at the electrode, and because oxidation occurs here, already this one is our anode. The positive ions, which are the copper 2 ions there, are going to be attracted to our negative electrode there, which is our carbon electrode, and it will gain some electrons from the electrode and become copper 2 atoms. So copper atoms. So we're going to have our copper 2 plus aqueous ions are going to gain 2 electrons, and in the process we are going to form copper solid. Right? So what we are going to have now is that our copper 2 plus has been actually reduced to copper solid. This one is the cathode, although in our electrolytic process the cathode is negatively charged. So the reaction which is taking place here is a reduction reaction. Right? So our copper itself is going to be deposited on the electrode and becomes and because reduction occurs here, this is the cathode. Right? So that is what we have as far as this electrolytic process which is happening in the decomposition of our copper 2 chloride solution is concerned. Right? Another example of an electrolytic process which is also occurring is what we call electroplating. Right? So first of all, there is need for us to define what is electroplating. So the definition of our electroplating itself is the deposition of a metal coating onto an object by putting a negative charge on it and putting it into a solution which contains a metal salt. So all what we are saying is an electroplating, an electroplatic process itself is just the coating of another metal with another metal, and as a result we will see to it that we are using an electrolytic process to do that. So the metal salt contains positively charged and metal ions which are attracted to the negatively charged object and are reduced to metallic form upon it. The refining of copper is also an example of such a process. We have our crude copper which is being obtained from the ore, and it will be having a lot of impurities and it can be used for electrical wiring. For example, this one is just an example of a process in which we are using our copper, in which we actually want to use it in refined form. So it will be containing metals such as lead, zinc, nickel, and silver. So it is supposed to be purified by electrolytic means. So large plates of crude copper are used as the anodes in an electrolytic cell, and then thin sheets of pure copper are made the cathodes. Right? The electrolyte is an acidified solution of copper to sulfate solution. So when the correct voltage is applied to the cell, copper metal is oxidized at the anodes. So what we are saying here is we are actually having our crude copper, which is solid in form, and then we are having it supposed to be electrolyzed to copper 2+, that is in aqueous form, plus 2 electrons. So this one will be an oxidation reaction, which is actually taking place at the anode. But remember, this one is an electrolytic process. Our anode will be positively charged. And then again, we have our copper 2 ions are going to be reduced to copper metal at the cathodes. So we are having our copper 2+ aqueous ions. They are going to gain some electrons, and then we are going to form copper solid. So the impurities collect below the anodes as the sludge from the metals are recovered. So what we are saying there is that we have formed our copper solid there. Our copper solid, we are going to see to that it is going to increase in size on our cathode. Why? Because this one, as you can see, we are forming more of the copper, and this one is a reduction reaction. So if we can actually see this one, we can actually say that we have purified our impure copper into pure copper. So electroplating has been actually done in order for us to actually purify our copper. So our cathode is going to be coated with pure copper, and so it is going to increase in size. And then on the other hand, we see to it that our anode itself is going to decrease in size, and so that's why we are saying that this one is an oxidation reaction. So therefore our copper itself is going to be purified by an electroplating process, or using what you call electrolytic process. So with this, stay tuned for lesson number 8. In this lecture number 8, that is where we are going to look on the industrial electrolytic processes. With this, I would like to thank you.